So I know when I was getting started woodworking, one of the tools that made me the most nervous outside of maybe the table saw was the router. And I think that makes sense. This thing is spinning a sharp metal bit at thousands of RPM. You're holding it in your hands, and a lot of times the only thing between that bit and your hands is whatever workpiece you're working on. And if you accidentally run the router in the wrong direction or take too deep of a cut and the bit gets bound up, the router can be ejected out of your hands and cause some real havoc. Or if you're using a router table and you do something like that, your workpiece can be pulled out of your hands and your hand can be pulled into the bit. So it's definitely a good idea to know how to use a router properly before getting started with one. I actually think the first time I ever used a router was on camera. I was building a thin line Telecaster, one of my earliest woodworking projects on this channel. Go check out that video if you want to see me 8 years ago and see how far my shop has evolved since then. But anyway, I've collected a list of about 10 tips to help you get going with your router or just become more proficient with your router if you already have one. And I'm going to go over the different types of routers, different types of bits, how to actually set up your tool for the best results, as well as some safety tips so you don't end up missing a chunk of your finger by the time you're done with your project. So first things first, let's go over the different types of routers. And there are two kind of basic categories. You've got your trim routers and then you've got your full-size routers. The main difference is the form factor and the power. These trim routers are going to have a lot less power. Usually the collets that come with them, the part that actually holds the router bit, is only going to go up to a 1/4 inch shaft, so it's only going to accept smaller router bits, whereas these full-size routers are a lot more powerful. They usually come with multiple collets going all the way up to 1/2 inch, so you can use some really large bits in these. And if you don't know what you're doing, this is definitely the kind of router that can make you pretty nervous around working with routers. The other big distinction between router types are going to come down to the types of base they come with. As you can see, this is a fixed base, meaning there's no plunge mechanism. You can still adjust the depth of cut very easily. You basically just slide the body of the router up and down until you have the depth of cut you want. But then when you have a router with a plunge base, as the name implies, you're able to plunge the entire router, which is really great if you want to start your bit above the workpiece and plunge in. Let's say you're cutting out a pocket or a dado that's stopped in the middle of the piece. It can be really handy to not have to try to kind of angle the bit in. That can get really sketchy really quickly. Now, a lot of these trim routers do have plunge bases available, so plunge versus fixed base isn't really a style of router. It's more of a style of base, but a lot of times that can be confusing when you're getting started. But for example, I have a plunge base and a fixed base for this DeWalt router, and I might want to use the fixed base for certain operations and the plunge base for other operations. For example, if I'm just adding a quick little round over or chamfer to the edges of a project, a fixed base is great because you get rid of all the bulk of a plunge base, you still get a nice stable platform, and you can easily control that router one-handed. Speaking of bases, another great accessory you can pick up is a larger base for your fixed base. This essentially just gives your router a lot more stability, especially when you're working on the edges of a workpiece. You can get them in all different sizes and formats. This one actually came with this Milwaukee trim router. This is another example of an aftermarket base plate. This one has handles added for a little bit extra control of the router. But just know if you have a fixed router, that doesn't necessarily mean you're locked into it and have no plunge base options. Now, as far as specific router recommendations, that's really going to come down to budget and the types of operations you're going to be doing with your router. If all you're planning on doing is adding an 1/8 inch round over to the edges of your projects, a trim router will be plenty powerful enough for that and will be very easy for you to use. If you want to add much heavier edge profiles like large chamfers or want to start cutting a lot of joinery with your routers, you might want to consider moving up to a larger full-size router. This is obviously a very expensive full-size router. This is made by Festool. None of these tools are sponsored, by the way. I'm just showing you what I happen to have in my shop, but just know there are a lot more budget-friendly full-size routers out there than this one. So next, let's talk about router bits. And this is a small sampling of the router bit collection I have. When I was getting prepped to make this video, I realized just how many bits I have. It's kind of insane, but I personally like to have backups for my backups in case I break a bit mid-project. I keep a lot of router bits on hand. So many bits. First and foremost, I would probably avoid buying router bit sets. I think a lot of times those come with bits that you will never end up using. I know there are a lot of really strange edge profile bits that I know personally I am not a fan of the look of. So in my opinion, I think you're a lot better off just buying the bits you need project by project. It'll save you a lot of money in the long term, and it'll mean you can invest in better quality bits from the start, which I think is way more important than having a million different router bits. So the first category is going to be straight bits, or they can be called in mills depending on where you purchase them. But basically these are just chunks of steel with a carbide edge. Sometimes the entire router bit is made out of solid carbide, and those cutting edges can either have a spiral shape or a straight shape. Now personally, I've moved to almost entire spiral router bits where I can. I think you get a lot better cut quality, you reduce tear out. Overall, I just think they work a lot better. Now that being said, spiral router bits I think are usually a little bit more expensive than straight router bits. They're also a little harder to find. It's not as easy to walk into your local big box store and grab something like a spiral downcut end mill versus something like this straight two-fluted bit. But anyway, these straight bits or end mills are great for all kinds of different routing operations. If you're cutting in things like dados or grooves, all kinds of joinery, they are perfect for that. If you combine end mills or straight bits with something like a brass guide bushing, you can turn them into essentially pattern bits, and that'll save you a lot of money versus buying a boatload of specialty template or pattern bits. You can keep a few straight bits or end mills on hand and then just use different guide bushings depending on the project and jig you have set up. The nice thing about these brass guide bushings is making the templates is super simple. As you can see in this case, it's just a piece of plywood. I screwed down a stop at either end and I was good to go. Speaking of which, I know I've mentioned in the last couple videos, but I am really enjoying these hyper tough tools. I've been using their drill, angle grinder, bit sets, and inverter, and they are all great, especially for the money. And I'll link to them in the video description below in case you want to check them out. In the world of spiral bits, you also have a ton of different options. First, you need to decide what direction the spiral is going. You can either have a down cut bit, which is going to push the chips down into the workpiece. It's also going to push those wood fibers on the surface of the piece down, which should help to reduce tear out. You've got upcut bits, which are the exact opposite. They pull the chips out of the workpiece, but they can increase tear out on the face of your workpiece. And then your third option is a compression bit, which is a combination of an upcut and a downcut bit. And these are awesome as long as your router can handle making a deep enough initial pass to actually get the advantage of that compression bit. Because the way a compression bit is designed is that the first half inch or so is upcut and then it changes to downcut. But if your initial pass isn't deep enough to get to that downcut portion, you're basically just going to be using an upcut bit and risking all of that same tear out. But if your router is powerful enough to run one of these things, they can be great because you can get the advantages of a downcut bit with that minimized tear out, as well as the advantages of the upcut bit pulling out those chips for better dust collection. If I was just starting out, I'd probably pick up a 1/4 inch downcut spiral bit, as well as a 1/2 inch either straight bit or spiral bit, and that should allow you to do a bunch of different joinery no matter what kind of router you have. Next on the list is going to be roundover bits and chamfer bits. Basically, this category covers all the different edge profile bits, but I know personally, I pretty much only use roundovers and chamfers. These edge profile bits can really make a huge impact on the overall look of your finished project. And I think getting some of these on hand will massively upgrade your woodworking projects. If you've just been kind of sanding in your edge profiles by hand, it's never as consistent and good looking as something like a dedicated roundover bit or chamfer bit. So I would highly recommend picking up some good quality bits for this kind of work. As far as specifics, I mostly use 45-degree chamfer bits because most of the time I'm really just wanting to break the edges of pieces. I do have a pretty monstrous chamfer bit that's great for undercutting the edges of tabletops, but you need a pretty powerful router to run that bit. And honestly, I probably need the bigger version of this Festool router for that bit. In the world of roundovers, you have a ton of different options in terms of radii. I think the roundover bit I use most often is a 1/8 inch roundover bit, and that's because this bit really just does what you'd be doing by hand anyway, hand sanding and breaking those sharp edges, and it gets it done a lot more quickly and consistently. You can also go to the opposite end of the spectrum and add heavy roundovers to your edges, and that can look great for things like mid-century modern furniture. And I personally also use heavy roundovers on a lot of my shop furniture, just so I don't bang into them while I'm working around them. One thing to keep an eye on with your edge profile bits is the condition of the actual cutting edge. For example, this chamfer bit somehow got nicked on its cutting edge. It must have hit a brad nail or something like that. And unfortunately, when I use this bit, it leaves a ridge in all of my chamfered edges, which I then have to sand out, and it's a total pain. Hard to see on camera, but the ridge is right there. This one's not gonna be in the garbage quite yet because that's pretty easy to sand out. Unfortunately, I don't think there's a great way to fix this. I could maybe try to sharpen this by hand, but it's really easy to make a router bit unbalanced with too much sharpening, and so I'll probably just end up buying a new router bit to replace this one. The next big category of router bits to go over are template bits or flush trim bits. And these are incredibly handy in woodworking because a lot of times you're gonna wanna make a template and then make a bunch of pieces that look exactly like that. And the easiest way to do that is to use a flush trim or a template bit. Once again, these come in all different shapes and sizes. This behemoth of a bit is, I think, my largest flush trim bit. This thing is absolutely insane and is pretty terrifying to use the first time you spin it up on your router table. I definitely would not use this in a handheld router because if you don't treat this thing with respect, it's gonna grab your workpiece and throw it across your shop. But as far as the size of flush trim bit you're gonna wanna purchase, again, that's gonna depend on your router and how powerful it is. If you have one of these trim routers, I would say something like a 1/4 inch flush trim bit is a great pairing with that. You definitely don't wanna try to hog away too much material with those smaller bits because even though they're metal, that 1/4 inch shaft can definitely deflect and cause all kinds of problems in your finished workpiece. If you have a beefier router or a router table like I do, you can definitely start investing in some of these larger bits. They're gonna allow you to work a lot more quickly, they can remove a lot more material, and you're gonna be left with a really high quality surface finish. Another bit type I would include in this category are pattern bits or template bits. These are similar to flush trim bits, but usually they only have one bearing versus the two bearings, one at the top and the bottom, like you see on a flush trim bit. Usually they are gonna have straight cutting edges, so you do need to be a little bit more careful paying attention to your grain orientation and your depth of cut, but you can definitely get great results with these, and they're a lot cheaper than these bigger spiral flush trim bits. Besides those bits, there's a whole world of other router bits out there, and this entire video could be about router bits if I kept talking, but a few others that I figured I would mention that I think are very handy, especially when you're first starting out, are rabbiting bits, which are great for cutting, as the name implies, rabbets on the edges of your workpiece. There's also all kinds of specialty router bits. This is a dovetail bit. You can also get T-slot bits for cutting your own T-track. You can get keyhole bits for cutting keyholes on the back of projects you might want to hang on the wall. There are a ton of bits out there, and again, just do your research and figure out the ones you want and just buy the ones you actually think you're gonna use. Don't just buy a huge set of dirt cheap bits off of Amazon. I think you're gonna have a pretty bad time if you end up doing that. So moving on to tip number 3, and this really ties in with your bit selection from tip number 2, and that is to set the speed of your router correctly. And I know this is something I definitely didn't understand when I was first getting started. I think I assumed that the highest speed would be the best because that's the most power, and you want the most power, right? When in reality, that is definitely not correct. For the most part, every router bit manufacturer is gonna include some sort of RPM guidelines, and once you have those, you can look in the manual for your router and kind of roughly match up your settings on your router with the guidelines from the manufacturer. Obviously, that number is going to vary a ton depending on the material you're cutting into, your depth of cut, all that kind of stuff, but that's a good baseline for getting started. As far as real world numbers, when I'm doing things like light edge profiles, like light roundovers and chamfers, I usually bump up the speed a little higher, maybe a 4 or 5 or 6, depending on the scale on your particular router. And as long as you're moving your router along quick enough without doing a bunch of stopping, that's gonna give you a really good cut quality while avoiding burning. Now, on the opposite end of the spectrum, if I'm using one of these massive flush trim bits or another bit where I'm removing a lot of material, I turn that speed way down. In the case of this flush trim bit, I turn it down as low as it'll go. Same with the large chamfer bit I mentioned earlier, because the last thing you want to happen is for that bit to catch if it's spinning really, really fast and then yank that workpiece away from you, because it has the potential to pull your hand in at the same time. Moral of the story, mess around with the different speeds, see what works for your bits, your router, and the project you're working on, and go from there. Tip number 4 is to secure your workpiece properly, because the last thing you want is your piece wobbling around or falling off your workbench while you're working. Routers can exert a lot of force, so at a minimum you want to have some kind of grippy surface under your piece if you're using a handheld router. I really like using these bench cookies. There are tons of other grippy type items you can use. I know I've used those grippy shelf liners in the past, and those work great as well. If you're not doing a bunch of work on the edges of your project, you can definitely clamp your project down to your workbench, and this is great if you're doing things like cutting joinery. But again, if you're trying to add chamfers or roundovers to your entire project, those clamps will definitely get in your way. Tip number 5, and I think this is the one that hangs up most people, is to know which direction to run your router. And this can be pretty confusing because that direction changes depending on whether you're cutting on the outside or the inside of a workpiece. But the thing to remember here is that your router bit is spinning clockwise. So if you're routing on the outside edge of a project, you want to be going counterclockwise to resist those cutting forces. Otherwise, your router is going to be running in the same direction your bit is cutting into the wood, and that's when your router is likely to grab and kind of yank away from you because you're not resisting those cutting forces. Now, if you're cutting on the inside edge of a workpiece, the rules are opposite. You want to go clockwise because again, you need to think about where that bit's contacting and how it's interacting with your workpiece. When it comes to cutting something like a dado in the middle of the workpiece, it doesn't really matter which direction you move the router, at least on that initial pass. Because if the dado you're cutting is the same size as the bit you're using, that bit's going to be in contact with both sides of the cut simultaneously, so you can kind of go whatever direction you want. Now, if you're using something like a 1/4 inch bit and need to cut a 3/8 inch wide dado, then you need to start paying attention to the direction of your cut after that initial pass. When it comes to the router table, travel direction is usually a lot simpler. You basically want to be going from right to left. Again, unless you're cutting the inside edge of a workpiece, then you want to be going from left to right. Tip number 6 is to set your bit depth and start with light passes. So first of all, when you're installing your router bit, you don't need to slam it all the way home in the collet. As long as there's about 1 inch of that router bit shaft in the collet, it should hold just fine. Also, you don't absolutely need to crank down on the collet. As long as it's pretty snug, you should be fine. Once your router bit's installed, then you need to set your depth of cut. And on something like a plunge base, that's pretty simple. What I do is take the plunge base, put it on my workbench, and then plunge the router down until the bit hits my workbench. Then I know that's pretty much my 0. And then most plunge bases are gonna come with some sort of kind of scale indicator to tell you how deep you're cutting. Once you have your bit zeroed out, you can zero out that scale. And then if you wanna make, let's say, a 1 inch deep cut, you can set your depth stop to 1 inch. And then you've got these little, what are called turrets here underneath your depth stop that allow you to make multiple passes, taking a little bit more material with each pass. Now, if you're doing something like adding a chamfer to an edge with a trim router with a fixed base, that's also pretty easy. What I like to do is take my bit, go ahead and get it installed, and then I can get a piece of scrap and basically line up the very corner of that cutting edge with that scrap, so I know my bit's gonna be perfectly zeroed out. Now, especially when I'm using a roundover bit that's set up for the first time on a router, I like to run that first pass on either a scrap piece or make sure I know the bit isn't quite to full depth, because the last thing you wanna do is cut in a roundover with it set way too deep, because it's gonna leave this huge groove around the edge of your workpiece that's gonna be very difficult to get rid of.
That ridge.
And that's why a lot of more production-oriented shops actually leave certain routers set up with certain bits all the time. For instance, if you know you use an 1/8 inch roundover bit on pretty much every project, you could set up one router with a 1/8 inch roundover bit dialed in perfectly, and know you can just grab it and go anytime you need to do that work without fiddling with a bunch of setup. The other thing to mention when it comes to setting depth is that most routers, whether that's trim routers with a fixed base or full-size routers, come with some sort of micro adjust functionality. And this is really handy when you're doing things like dialing in the depth of cut on a roundover or something like that, because it allows you to sneak up on that cut depth very easily without having to make huge adjustments to the router and just kind of guess. So in the case of this Milwaukee router, it's this little knob here. On this Festool router, you've got this green knob here. On this DeWalt plunge base, you've got this little knurled micro adjust knob. So hopefully your router has that feature built in, and if not, you might want to consider upgrading because it is a pretty handy feature to have. Now, as far as how much material you want to take per pass, again, that's really going to depend on your specific router and bit setup. A good rule of thumb is to start with a depth of cut equal or less than the diameter of the bit. So let's say you're using a 1/4 inch end mill, your depth of cut should be 1/4 inch or less. Tip number 7 has to do with using a router with some kind of edge guide or fence. And a common mistake a lot of beginners make, and I know I did this as well early on in my woodworking career, is to think that you want to run this flat edge of your router base up against your fence or guide. And that seems like it would make sense because it's nice and flat. It would ride up against that guide perfectly. But unfortunately, when you do that, it gives you basically 0 wiggle room for moving your router out of alignment with that fence. Otherwise, your bit is going to go off course and you're going to be left with a pretty bad looking cut. Instead, you want to run this rounded edge up against your guide, because that way, no matter how you move your router in this orientation, as long as it's pushed up against the guide, it's going to continue cutting in the same spot, and it'll leave you with a really nice clean cut.
Yeah, slight difference.
And I remember when I personally learned this the hard way when I was making the assembly table sitting right over there. I was running my router with the flat edge up against the track saw track, and I got a little bit squirrely with the cut and made the groove for my T-track way too wide, and that is still there today. And thankfully somebody in the comments of that video pointed that out to me, and I committed that little pro tip to my memory from then on. Tip number 8 is to keep your router bits sharp and clean. And I know this is one I am definitely personally guilty of. I know I gave that example earlier of this chamfer bit with the little nick in it. That hasn't really stopped me from using it. And also on this same chamfer bit, you can see where some of that pitch has built up on the inside of the cutting edge. And that's something that really should be cleaned up. There's all kinds of different ways to clean router bits and saw blades. I know Simple Green is a pretty popular one. But basically, you just want to remove all that gunk, and that'll just help to keep those router bits from overheating and keep them running nice and smooth. Tip number 9 is to wear your safety gear. Obviously, routers create a ton of sawdust and chips can fly off of your workpiece. So at a minimum, you should be wearing safety glasses and hearing protection. I know I personally invested in this dust mask recently. Hold on, let me take this off so you guys can actually hear me. This is a positive pressure dust mask. Basically, it sucks in air through these filters, blows that air on your face, and the positive pressure keeps you from breathing in the airborne dust. Now, I avoided buying one of these for years because they're really freaking expensive, but I figure it's better to spend $500 now than to die of lung cancer in 20 or 30 years. And these are way more comfortable than the typical respirators I've been using for the last few years. And so hopefully having this will mean I actually wear it instead of avoiding using it like when I had the regular respirators. Tip number 10, and this is really more for the beginners out there, is to keep a firm grip on the router even if things start to get a little squirrely. Because I think one of the worst things you could do is, if the router starts to catch or whatever, would be to just let it go and back away, because again, that bit's still spinning. It could launch off in all kinds of different directions, do all kinds of damage to your workpiece, to your floor, to you. So if your router starts to catch, just back off the cut a little bit, go in the direction you came from, and then turn it off and then walk away. Because the last thing you want is an out of control router flying around your shop. And tip number 11, which kind of goes hand in hand with tip number 10, is to turn off your router before setting it down. And I know I have personally been guilty of this for sure. Routers can take a few seconds to spin up or spin down. And if I'm doing something like adding an edge profile and a clamp's in my way, I have definitely sometimes set down the router, moved the clamp, and then picked it back up and continued routing. But just think about it. If you have dust collection going and you got hearing protection on, and maybe you're a little sleep deprived or just distracted for whatever reason, it would be very easy to forget that router is still running, grab it near the bit, and mangle your fingers. So I would always get in the habit of turning it off before setting it down. I think this is even easier with these newer battery powered trim routers because they spin down almost instantly, and so you really won't be losing much of any working time by turning it on and off every time you set it down. If you guys have any router tips that I didn't include, leave them in the comments. I swear I learned something new in the comments of every one of my videos, so keep those coming. I'll link to these routers, the bits, and all the other gear I talked about in the video description below in case you want to check that out. If it's your first time here, go ahead and get subscribed and ring the notification bell so you don't miss my future videos. And last, while you're here, why not check out this other video of mine that YouTube thinks you'll enjoy. All right, thanks for watching, y'all, and until next week, happy building.